All right. Good morning to Elements Calculus 2 people. Today we are going to talk about one of the more influential topics, more important topics that we're going to be dealing with, and that is integration by parts. Let me quick tell you where it comes from. It's not that long, I promise you. So remembering back in the day when we took the derivative of two functions, u and v, we said product rule, right? We have the derivative of the first times the second plus the first times the derivative of the second. So that's how I do that. Now, the next thing I'd like to do is I'd like to kind of preserve my u v tick here. So I'm sorry. Yes, I'm going to preserve my u v tick here and sheet the other one over the other side. So we're going to say this is going to be the derivative of u v minus u tick v is equal to u tick. And then what I'm going to do is I'm going to integrate both sides. So I'm going to integrate both sides. So we have the integral of derivative of uv minus the integral of u tick v is equal to the integral of u tick, right? Now, by fundamental theorem of calculus, we go ahead and say that this is just going to be v. We can't do very much with this. So this is just going to be the derivative of tick v, and then we're going to have equals to u tick. So this is a formula you might want to memorize. And I'll show you a different way to set this up so you don't have to memorize a formula, but usually they write the uv tick equals the other stuff. So it's usually uv tick equals uv minus the integral of tick v. Usually how you're going to see this thing. But again, I would urge you not to memorize the formula. I'll show you how to set it up so it makes a pattern and you won't have to memorize the formula. Just if you memorize the pattern, you're not going to worry about too much. Okay, so the canonical example for why do we need integration by parts is how do we integrate the natural log of x? Now remember, we know the derivative of natural log, we do not know the integral of natural log. So what we have to do is integration by parts here. Okay, so we'll say this is IBT, integration by parts. So we'll say u is equal to, I know the derivative of natural log. You always want to pick something you know the derivative of here to set that up. Now the dv, in this case, is a little tricky. Only part we have left, right, is this dx. So we're just going to pull that aside here. Now the next thing we do is we say, okay, what's du? This was 1 over x. And then we have to figure out, we'll put the little dx in here for the differential there. And we'll have our v, we have to integrate what is the integral of dx, we just end up with an x. Don't worry about the c just yet, that'll cover the end. Okay? And then all we have to do is say uv times v du. Remember that was our formula? uv minus v du. So that's how we're going to go ahead and do this. So you set this little box up, all you have to do is diagonal and then across. And that's your integration by parts. So we're going to say uv, which is x ln of x, minus the integral of this piece here, x times 1 over x dx, right? So we're just going to have x ln x. Now this has already been integrated. We're okay with that. Minus integral of x over x is just going to be 1 dx. That's a nice integral. So we have x ln x minus x. Now we put in our plus c because we are at the end of our integration factor. Okay, so at the end of integration problem, we put in our plus c. And that is how you do integration by parts. Okay, let's do at least a couple of examples because this is one of those techniques that is really worth knowing because this works for a lot of different kinds of integrals. So let's go ahead and take the integral of x times 2 to the x dx. This is one of those exponential types that doesn't have an e in it. So everybody in Calc 1 is like, oh, do we have to do more e's? E's are easy. This one's a little bit on the hard side because what we're going to do is we're going to say, okay, anytime you have a polynomial times an exponential, it's going to be integration by parts. Polynomial times logarithm, integration by parts. Okay, so we're going to say let u equal What's the easiest thing I can find the derivative of? X. Let's go ahead and let that one be. You're not always going to pick the right u. You're not always going to pick the right dv. But usually, with a little bit of practice, they're set up so you will get the right one. So just be dx. Okay, dv is equal to 2 to the x dx. Now, I don't know about you. I don't remember how to integrate this off the top of my head. There's a formula for it. I don't remember. But a fancy way to write 2 is e to the natural log of 2. Okay, that's e and natural log, just cancel out. So that's how you write 2. And this is all raised to the x. So we have 2 to the x. And then, of course, we're going to use our rules of exponents. We have e to the ln 2 times x. Now, can you integrate what e to the kx is? Because natural log of 2 is just a constant. You remember that integral is 1 over k e to the kx. So integrating this, we end up with e to the ln 2 raised to the x power, raised to 2x here. Let's go ahead and put that extra step in just to take it out later. So we have, and then we divide it by ln 2, just like this 1 over k. That's all this is. It's k. So that's what we have here. So clean this up a little bit. So we've got u was equal to x, du was equal to dx, dv was equal to 2 to the x dx, b is equal to 1 over ln 2 times 2 to the x. Okay, so let's go ahead. Now we're going to apply our integration by parts. It was uv, so that's x times 2 to the x over ln 2 minus the integral, right, of 1 over natural log 2 times 2 to the x dx. Do you remember what the integral of 2 to the x was? Oh, it was 1 over natural log 2 times 2 to the x. Okay, so that's already listed there. So here we have x times 2 to the x divided by natural log of 2 minus, I'm going to move this 1 over ln of 2 out, integral 2 to the x, just so it's really easy to see. It's like, what's the integral of this thing? And we're just going to say this is going to be x 2 to the x over ln of 2 minus 1 over ln of 2. There's another 1 over ln of 2 times 2 to the x plus c. So what we're going to end up with is x 2 to the x over ln 2 minus 1 over ln 2 squared. There's not much you can do with that. Okay, times 2 to the x plus c. And that's going to be our answer for this integration by parts problem. So sneaky of me to introduce you to integration by parts, but also remind us of what a to the x would be. So with that purpose to kind of sneak that in. All right, let's do another example. Right. So this one is a pretty common type of problem. We have integration x squared e to the negative x dx. So here we're going to say, okay, what can I take a derivative of? We have naturally, we have let u equals x squared. dv equals e to the x dx. And now we'll go ahead. What's my derivative? du is equal to 2x times its differential, dx. b is equal to negative e to the x. Okay, so let's go ahead and put this together. We have uv, that's x squared, negative, I'll put the negative out in front with that, e to the negative x, minus a negative, so I'm just going to put the plus in, integral of 2x e to the negative x. And then we have our plus c. Hang on to that one for just a moment. Anytime you have a polynomial times an exponential, you're probably going to be using integration by parts. So, we have to do this one again. So we're going to say, leave this one alone. Now we have to do this part B. We have this little mini problem. We can pull this 2 outside of the integral, so we don't have to look at it. We'll say, let u equals x, dv, again, equals e to the negative x. du is just dx, v is just going to be negative e to the negative x. So we have to pull this one around. So this is going to be negative x squared e to the x plus, excuse me, 2. And now, what is this? We're going to have negative x e to the negative x here. That's this diagonal minus, but notice we're going to minus a negative. So minus a negative integral e to the negative x dx. Okay, that's this part right here. Now, this part, we can say, okay, I can integrate e to the negative x. That's pretty good. So we have negative x squared e to the negative x. E to the negative x, there should be a negative here. Plus, don't forget to factor this out. We have a minus 2x e to the negative x. Let me make that clear that that's a minus there. Oops, I don't want to highlight. I want to draw. So we have a minus, and then we have here, we have, we're going to integrate e to the negative x. So we still have a minus because we're going to have e to the negative x, and then 2 times this whole thing, plus c. Now, there's some things that are consistent through everything here, okay? And I see a negative e to the x everywhere. So I'm going to go ahead and factor out. We have e to the negative x. What's left, I have an x squared. Pull the negative sign out. So we have plus 2x plus 2, and parentheses, plus c. This would be my answer to this integration by parts. It is not unusual. You would have to do this more than one time. I'm going to show you a little shortcut with that called tablature integration. Okay. If you go through other YouTube channels and type in integration by parts, they will probably demonstrate this technique to you. I just want to warn you, it doesn't work all the time. It works most times, but there are ways you can mess this up. So you have to be kind of careful about what you're dealing with. So we have to integrate x squared to e to the negative x. Okay. So what we're going to do is we're just going to write that we want a derivative column, we want an integral. So we're going to say we have our x squared here, we have our e to the negative x. Every time, by the way, in integration by parts, you want to account for all the different pieces that are sitting in. So I got my x squared e to the negative x. Everything has to be accounted for when you set up your u and your d. And then we're just going to start taking derivatives. Derivative of x squared is 2x. Integral of x is negative. We're going to take the next derivative. Derivative of 2x is just going to be 2. The derivative, or the integral rather, of negative e to the negative x is going to be positive e to the negative x. Take the next derivative. We get 0. Once you end up with a column or with a row that is 0, you know that that's the last column that you have to deal with. Okay? And then what we're going to do is we're going to put in the signs, SIGN signs. So you have a plus, negative, plus, a negative. Okay? What we're going to do is we're going to say, okay, we need, so it's just this period in the diagonal. So we're going to multiply these together. So this is going to be negative x squared e to the negative x. And what about the plus sign? We have a minus sign over here. So we multiply, we have positive times a negative. We have a minus, we have 2x times negative e to the negative x. Okay, so we have a minus, we have this going on here. So that, oh no, sorry, diagonal, write the diagonals down. So we are good with writing that, spacing good. Okay, so that's going to be a minus, we got 2x times e to the negative x. And then we have a plus, okay, 2 times negative e to the negative x. And then after that, it's going to be 0 times something, but who cares what that's going to be. So once you have your 0, there'll be something down here, but 0 times whatever this is, it's a question. It's going to be a 0. Okay, so let's go ahead and regroup. So we have a negative x squared e to the negative x. minus 2x e to the negative x plus, remember there's minus here, so let's go ahead and that in as a minus. We erase that so it's clear what sign I'm talking about. Minus 2 e to the negative x. Okay, so I did with plus c. Now, what we're going to do is the same thing we did the last one. I'm going to put a negative x. What do we have left? We have an x squared. Remember, we pulled out a negative, so it's going to be a positive 2x. Remember, we pulled out this negative, so it'll be a positive 2 plus c. And I believe that is exactly the same thing we had up here. So this way was a little bit of a shortcut. I don't care if you ever do the shortcut. If you love the shortcut, that's all you want to do, that's fine. Just be careful that you have to be careful picking the derivative of the integral column. You have to be careful with your signs. You have to make sure you're actually integrating stuff correct. So there's a couple of caveats to how this works. And I'm always reluctant to show you this method because I always have students that this is all they do, even if it's not exactly the most appropriate thing to do. So they pick the wrong derivative or they pick the wrong integral. They kind of mess things up. So make sure you've accounted for all your pieces and go down and do this thing. But just make sure you've got all the parts in your integration derivatives are all correct. Okay, so you can use this, but just be careful when you do use it. So again, when you look forward, go ahead on the other YouTube channels and find, hey, I need to learn integration by parts. Can you help me? Here is where this class gets to be really hard. And it's not that the class is actually hard. So I'm talking to people who are actually taking my Elements of Calc 2 class. Generally, the people who take this are chemistry majors and biology majors. Chances are you've had organic chemistry, possibly 1 and 2. Organic chemistry is a much harder class than this is. So if you can handle organic chemistry, you can handle Elements of Calculus too. When you do, and you find on the other YouTube channels, like how do I do integration by parts, you're going to come across this acronym, across LIATE. It just stands for what are you going to make your U? So what are you going to take your derivative? What this comes down to is if you have a logarithmic function, make that your U. The I stands for inverse trig function. Okay. You will never encounter an inverse trig function in this class. You don't know how to take the derivatives of them, don't know how to take integrals of them. You will never see inverse trig functions, so you don't need this part of it. Algebraic, this is going to be your polynomial, so this is algebraic. This stands for anything that looks like a polynomial. T stands for trig. Well, we didn't deal with inverse trig functions. We aren't dealing with trig functions. So we got through the whole life so far without having to know what a sine or a cosine or a tangent was. We're not going to start now. Okay, so people in calculus for scientists and engineers, they think a whole other class that you didn't take called pre-calculus or perhaps trigonometry, where they learn all about these functions. You didn't learn these things. So if you're looking for a U that has like a trig in it, this is where it would go. But again, you will never see this kind of function in this class. So you don't have to worry about the I part or the T part of the LATE acronym. So I know other YouTube channels do it, and it works really well for calculus for scientists and engineers. But again, it's a rule of thumb, don't always use it. This will sometimes fail. And the last one is exponential, which usually is e to the x, but as we just saw in the previous one, if they have a 2 to the x or 3 to the x or pi to the x or something, that's going to be your exponential functions. Okay, so that's how you would pick your U. I would say, instead of memorizing this other thing, pick your U so the derivatives eventually go around to 0. That's usually the best way of doing this thing, and not trying to memorize extra stuff to figure this out. Okay, and I've got a trickier one here for you when it doesn't quite follow the t. So we have integral of x e to the x divided by 1 plus x. I think we have a square here dx. Okay, so we have to use integration by parts. We have a polynomial times an e to the x. Now, you have to be kind of careful with your u here. I don't want to pick u to be this whole thing. Okay, I don't want to pick u to be all of these parts here. Let's go ahead and erase or highlight this. I don't want to just wanted to draw a different color. Okay, I don't want to pick u to be this piece right here. And the reason why is because my du is going to be a quotient rule. I've lived most of my life trying to avoid having to do the quotient rule. Sometimes it's unavoidable, but most of the time I'll try not to do quotient rule. However, we can do product rule. I think that's the good choice here. Usually I'd say, okay, e to the x, but I certainly don't want to integrate this thing. Okay. Don't want to take the derivative of it. Certainly don't want to integrate. So we're going to say u is equal to x e to the x. dv equals 1 plus x to the negative 2. This is not a terrible integral. You're not always going to be guaranteed that these are always going to be. Again, you won't always pick the right u. You won't always pick the right dv. Okay, don't be afraid to like, oh, I didn't like that. Let me change my mind. It's fine. That's going to happen occasionally. Du is going to be a product rule. The derivative of the first, which is 1, so we have e to the x, plus the first times the derivative of the second. Okay, so that's the product rule. Derivative of the first times the second, plus the first times the derivative of the second. And now we have to go in the integral of this piece. This isn't going to be too bad. This is going to be negative 1 plus x raised to the negative 1. If you needed to do an extra little step in here to make sure you have all the parts here, that's fine. If you want to do a little bitty w substitution to kind of get this through, that's fine. Okay, do however many steps make sense for you to get the problem right. Okay, but now we have our integration by parts set up. Let's go ahead and see what happens. So again, we have our uv minus our v d0. Again, I would urge you draw the box and set up a pattern so it's got this thing to it, it's got a shape to it, and memorize the pattern rather than memorizing the form. Well, it's not too bad, it's just product rule backwards. So we're going to have uv, so we have x e to the x divided by negative 1 plus x, right? That negative 1 down, that puts down the bottom. And then we have negative in the integral, but because I have negative and negative, we're going to have e to the x plus x e to the x over 1 plus x. Okay, so that's counted for the negative sign. We have the negative 1 at the bottom, all set. Right here, before I do too much more, we could factor out an e to the x off the top here. So we're going to say this is negative x e to the x divided by 1 plus x plus integral. Don't put it on the outside, leave it on the inside, e to the x. And once I factor this e to the x out, we have plus x divided by 1 plus x, x here. So this cancels, okay? But that's a really nice problem now. So we have negative x e to the x over 1 plus e to the x plus integral e to the x dx. That's a nice integral. So we end up with negative x e to the x 1 plus x plus e to the x plus c. Now, allow me to do just a moment or two of algebra here, so I feel compelled to get the answer they have in the back of the where I got this problem. So we have e to the x here, so I'm just going to factor out e to the x. And I've got a negative 1 over 1 plus x plus 1. Now, wrote down the 1. The first thing I'm going to do is get a common denominator. What I'll replace this 1 by is 1 plus x over 1 plus x. Okay, so let me go ahead. Let me put an x back here because it was negative x e to the x, and I factored up. Since these now have common denominators, we can add them. So if I take this negative x and 1 plus x, those x's are going to cancel out. So we just end up with an e to the x. What I have here is 1 over 1 plus x plus c. And then we'll put the e back in. So we have e to the x over 1 plus x plus c. And now the answer looks like the back of the book answer, which makes me a lot happier. Again, if you ended up getting down to something like this, I think I'd be fine with it. You can go a little bit further, but I think it should be fine. So that's integration by parts. Do as many problems as you possibly can off of this section. You can use the tablature integration, that's fine, okay? But do as many problems as you can, because this is a really important topic. This will come up over and over again inside the class, okay? And once you leave the class and you do other things, it is very common that you're going to have like an x equals negative x kind of a problem. You're going to have to use integration by parts on this. Okay, so thank you very much for watching the video. Good luck, everybody, and I will see you in the next one.